So I may or may not have just accidentally paused that video and not hit play on it, so I just wrote all the notes without the video being on. So you'll have to bear with me and write the notes that I've already written. Major mistake. So our objective for today is to determine and explain unknown angle measures using a variety of theorems. We're going to start with some triangles, and we're going to talk about different types of triangles. There are two ways to define triangles, either by their sides or by their angles. The first type of triangle is an isosceles triangle. It has two equal sides. The next type, and it looks like that, the next type is an equilateral triangle. It has three equal sides, and they look like that. The next type is a scalene triangle. It has no equal sides, and they look like this. We can also define triangles by their angles. Start with acute. All angles are less than 90 degrees. Right, one angle is 90 degrees. And obtuse, one angle is greater than 90 degrees. We could also describe triangles as being equiangular. That means all the angles are equal. And that's really the same as equilateral. So we're going to talk about why triangles have 180 degrees in them. In fact, we're going to prove that all triangles have 180 degrees in them. So I'd like you to start by drawing this diagram. Okay, we've got some parallel lines. And I want you to draw two transversals, one going from here to here and the other going from here to here, and number the angles like I have them numbered. 1, 2, 3, 4, 5, 6, 7. Okay? Now, what I know is that 5, 6, and 7 are a linear pair. Even though they're not a pair exactly, they form a straight line, so they add up to be 180. Measure of angle 5 plus measure of angle 6 plus measure of angle 7 equals 180. I know that 7 and 1 are also equal because they are alternate interior angles. And angle 4 and 5 are equal because they're also alternate interior angles. Now I can do some substitution. I can replace 7 with 1, and I can replace 5 with 4. Because 5 is equal to 4, so I can put 4 in for 5, and I can put 7 in for 1. And 4 plus 6 plus 1 equals 180 by substitution. So this is why triangles add up to be 180. There's one other proof I'd like to talk about. It's called the exterior angle proof. Or exterior angle theorem, sorry. So on the next page, alright, the exterior angle theorem. Okay, and I want us to draw this picture. We're going to draw a triangle with one of the sides extending out. Okay, and what we're going to prove is that the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. Or the exterior angle, this one out here, the one on the outside, equals the two remote angles. Exterior angle is equal to the two remote interior angles. Okay, so remote means far away. These two angles are far away from this angle 1, and they're interior, they're on the inside of the triangle. So let's prove this. The measure of angle 1 plus the measure of angle 2 equals 180. Why do they equal 180? They're a linear pair. Okay. I also know that 2 plus 3 plus 4, those three angles, equals 180 because they're the sum of angles in a triangle. So now I have two things that are both equal to 180. So I can replace the 180 in this equation with the measure of angle 1 and angle 2, because the measure of angle 1 and angle 2 is 180. So the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals measure of angle 1 plus the measure of angle 2. And I can simplify this equation a little bit, and I can subtract the measure of angle 2 from both sides. So I knew this first one by substitution. Okay, and I can subtract the measure of angle 2 from both sides. That cancels, and I've got the measure of angle 3 plus the measure of angle 4 equals the measure of angle 1. So how can I use this practically? Well, let's say I had this nice triangle. I knew this was 110 degrees. I knew this was 60 degrees. If I knew this was x degrees. Okay, if I wanted to find the measure of this angle, I'd simply take 110 and set it equal to 60 plus x. So 50 is x. It's a nice, neat, fast little way of figuring out the value of an angle of a triangle. So that's it. I'm sorry that I wrote the notes without turning on the video. Have a great evening.